This is day 4 of the national qualification event. We had relatively little to do for the last 2 days. So we took some time going through the data, and Henrik made these wonderful animations of what happens inside Stanley. This is the work of the computer vision group on finding drivable surface, applying real-time machine learning to learning road models or models of drivable surface. What you see here is video from Stanley during its first qualification run, the flawless run, as we now know. And you can see a trapezoid in front of the vehicle that's being extracted from the laser map, which you can't see, as flat. And it's being used for training a machine learning algorithm to find models of how does this flat stuff look like. And that's being applied to the entire scene, and the scene is now labeled essentially in 2 colors. Red means, it looks just like that stuff, and green means it looks different. Different for us is obstacles. We use this to warn Stanley of obstacles at a range. Here beside the tunnel, you see how the machine learning zooms into the colors of the tunnel, and as it exits the tunnel, the color is quite different, but as soon as its trapezoid has covered enough ground outside the tunnel, its internal model is changed using its machine learning techniques, and is now able to recognize the grass. The important thing to notice here is there's a number of false negatives, regions that are drivable but not recognized as such, but every obstacle that we see here is quite reliably recognized. You see the traffic cones in blue, which means they're being seen just fine by Stanley. Same with the stack of tires on the left. And there is a car coming up over here, and Stanley's vision routines see it just perfectly well, which is required for us to be able to drive. This is a laser display. We have 5 different lasers. They come in different colors just in our display, so we can visualize them. You see Stanley, a little animated model of Stanley driving along the course. It's the initial gate that Stanley, of course, takes without any problems. And here you see a very simplified version of our grid map that's being constructed as Stanley goes. It reaches out maybe 30 meters or so max. The curvature in front of Stanley just indicates the steering direction. We found it if we just roll out a circular trajectory that corresponds to a fixed steering direction, you can actually visualize quite well how Stanley steers at any point in time. The first run in NQE we just found out recently has been the only flawless run, so we're the only team so far who's scored fully. There's 50 gates on the course, we passed them all, and there's 4 obstacles that we avoided. Every other team had some flaws or some collisions with something along the way. We've been conservative with regards to velocity. We found, of course, that others race faster than us. The fastest team was maybe about 45 seconds faster than us, I guess. So there's now some debate on how important speed will be for the final race. Clearly, we've put our effort into safety at this point and not into speed. So it's something we might change. We don't have a prediction for race day, but certainly something we are discussing at this point. This is the final stretch. You can see in the laser data the parked cars showing up just fine. Stanley swerving around them, and you can see the tank trap coming up in a second, and it looks really cute in the laser data. The laser data really clearly see the tank trap at a long range. In fact, there it's coming up. It's about a 25-meter range, and now it's coming to view. Here we go, and there's the tank trap.